This particular skill is on dilation, and we're going to go through a couple examples together. When I hear the word dilation, I always think of the eye doctor. If you've ever been to the eye doctor and they dilate your pupils so that they can see into your eye and see things more clearly, basically your pupil gets significantly larger. So when we dilate, we're going to change the size of something, either make it smaller or larger. The scale factor is what we will use to determine if it gets smaller or larger and to what degree it gets larger or smaller. So looking at the diagram, it says draw the image of the following figure after a dilation centered at the origin with a scale factor of 2. Okay. Being centered at the origin simply means that it's going to get bigger or smaller. The distance away from the origin is going to become larger, so out here, or smaller, more in towards the origin, at a scale factor of 2. The way to draw this diagram, then getting it, in this particular case, it's going to get larger. We're multiplying by a whole number larger than 1. So our value will come farther away and our image, I believe, will get larger. So the way we're going to do this is we need to identify the ordered pairs for the points on the diagram. Our first point here is at 6, 7. Another point at 9, 8. And a third point at 9, 6. Okay, and what we're going to do is we're going to take each of these values, our x values and our y values, and have them undergo an increase or a scale factor of 10. So we're going to multiply each of these values by a multiple of 2, or multiply by 2. So this becomes 6 times 2 is 12, and 7 times 2 is 14. 9 times 2 is 18. 8 times 2 is 16. 9 times 2 again is 18, and 6 times 2 again is 12. Now that each of those x and y axis values has undergone a scale factor increase of 2, we're going to plot the 3 ordered pairs, the new ones, and they will create the same figure but underneath the dilation on a scale factor of 2. So our new point is 12, 14, 12 on the x, 14 on the y. You can see how your image is going to be farther away from the origin. 18, 16, 18 on the x, 16 on the y. And 9, 6 now becomes 18, 12. 18 on the x, 12 on the y. And then I believe you'll use your straight edge and pencil to connect those. So yours will look much neater than mine. But here's your new image after a dilation on a scale factor of 2. You can see that the image is similar to the original, but is larger, twice as large, and then it's been dilated. It's been moved back away from the origin. Okay. In this problem, we multiplied by a scale factor of 2, which was nice to be dealing with those whole numbers so we could calculate mentally more quickly. But in many examples that you'll practice, you will not be multiplying by a scale factor that is a whole number. You'll be multiplying by a fraction, which is not a problem. You'll just multiply by fractions. And our second example will allow us to go through one of those together. This one now has a full completed triangle. So we still have 3 points, but it actually has a triangle that's completely closed versus the other one we did. There's nothing magical about the shape. You can dilate any shape centered at the origin. So this time we're going to draw the image of the following triangle after dilation centered at the origin with a scale factor of 2/3. So this time our scale factor is 2/3. So instead of multiplying by 2 like we did before, we'll be multiplying by 2/3. Our first step is again to identify the ordered pairs of each of the points of the image. So we have 6, 6, 12, 6, and 6, 9. And those are going to undergo a dilation of a scale factor of 2/3. So we're going to multiply 6 by 2/3. I'm going to make 6 6/1 and then reduce 2 and 1, and we get 4/1 or 4. And then this is again a 6 multiplied by 2/3, so this is going to be a 4 again. Hopefully that part makes sense. Let's capitalize on that. We've got another 6 over here in the y-axis, so that's a 4. And this 6 over here also then has to be a 4 when multiplied by 2/3. So while multiplying by fractions does seem a little more tedious than the multiplying by whole numbers, they are nice in that they give you some repeat numbers there. We're going to multiply 12 by 2/3, or you might be able to logic your way through that. 2/3 times 12. If 6 times 2/3 is 4, then 12 times 2/3 should be 8. But we'll just double check. In case we made an error the first time. We have 4 and 1 when you divide both by 3, and we get 8/1. So it looks like we're on the right track. 8. And then 9, could you logic your way through that? If 6 is 4 and 12 is 8, 9 would have to be right in the middle, which would be 6. But again, we'll double check just to make sure. 3 and 1 gives us 6/1. So 6. And then you're going to take to your coordinate plane and plot those. This one will be smaller. The triangle will be similar, same shape but smaller size, and will be pulled closer to the origin of the coordinate plane. So we're going to plot 4, 4 and 8, 4 and 4, 6. And then connect those with your straight edge. So you see the triangle, same shape but smaller size because the scale factor is less than 1, and it's been dilated back towards the origin a bit. Hopefully these two examples go ahead and get you started. Remember to use your shortcuts when you're multiplying. Look for repeat numbers or any mental math that you could use to logic an answer. And if you have any additional questions, make sure you ask your teacher as you practice. Thank you.